for all of us. Yeah, I think that it's time to start. Thank you everyone for joining our webinar. And today we are going to talk about how to run projects inside containers and how to compare that to running projects inside virtual machines. What kind of types of containers we run them with. Igor, maybe you can go to the next slide so we can show the agenda. Yeah, thank you. So yeah, what is more effective way for what kind of projects, for what kind of use cases, how we can scale virtual machines compared to containers and vice versa, as well as what pricing models are available at the market right now and what pricing model our companies are offering to make it even more efficient for you as a customer. And as well, today we are going to cover Kubernetes hosting, what kind of challenges you can face while running containers and managing them with Kubernetes, and what kind of solutions we can offer you. Also, you can keep in mind that today we're not going to have only like theory part, but also we're going to have a demo. Igor will show a demo how to run everything inside the platform. So Igor, let's go to the next slide. And I'd like to present who is on this call today. So from Jelastic Virtuosa team, as you might heard, Jelastic was acquired recently by Virtuosa. So right now we are part of Virtuosa team. We have Igor Kolodyuk, who is senior cross-platform architect, and he is one of the main guys, technical guys in Jelastic team, who was like building the product. So feel free to ask any technical questions. I'm pretty sure Igor can handle that. Also, we have Simon Ekstrand from Beebyte. Beebyte is our very great partner from Sweden, and you might know it already. So we are partnering like for this year already in production, and Simon is going to tell a few words about this partnership in a moment. And myself, I am director of product marketing in Virtuosa team. So again, I can answer some of the questions today, and feel free to comment, feel free to drop those messages in the chat. So Simon, maybe a few words about our cooperation, why you decided to make Jelastic Platform as a Service part of your product line, part of the functionality that you're offering to customers, and general journey with Jelastic and Beebyte.
Yeah, absolutely. So Beebyte started up around close to 6 years ago now. And as I'm sure a lot of our viewers already know, we are a hosting services company. We sell a lot of quite wide span of different hosting services, everything from basic web hosting and domains to a lot of server hosting using traditional virtual servers, VMs. And now through our cooperation with Jelastic, we also have entered the container market in a more organized way, in a structured way. The people behind Beebyte have been working with hosting for many years. I personally started doing this professionally in 1999. So it's soon going on 25 years. So we've been in the market for a very, very long time, and we have seen both a technical trend, obviously, and also a sales product trend that is moving towards container hosting in different ways. 15 years back, it was all dedicated servers, physical hardware. Then it shifted to virtual servers, and now we're seeing a maybe not quite as strong a shift, but a strong tendency towards container hosting for the slightly more complex scenarios. Oh, can you still hear me?
Yes, we are still here.
My computer flashed out here. Thank you. Yeah, so we were looking for a good way to be able to enter the container hosting market from a product perspective, and that's how we encountered Jelastic for the first time. Jelastic has a great offering around the technical needs of providing container services to customers in a lot of different ways. And like Tatiana said, we have now been running with Jelastic in production for, it must be at least over a year. And it has worked out very well for us so far. So we see this as a very good way to present container offerings to our customers in a structured and technically proficient manner. And yeah, we want to spread this word to our customers and as far and wide as we can. And this webinar is one way to do that, basically.
Yep, sure. Thank you, Simon. Yeah, just a few words about Jelastic in general. As you mentioned, yeah, something like 15 years ago, like there were no containers on the radar, but containers existed already at that point. And Jelastic platform is available in production for 10 years already. And right from the beginning of creation of this product, we were using containers inside. But at that time, containers were not so well populated. And Igor today, he is going to show why we decided to go with containers at once and what type of containers we decided to use and why we decided to use this specific type of containers. So I think that's the time to go on to the technical side of this talk. Yep.
Let's start.
Yep.
So first, let's synchronize about the terms, about the phrases. So we know all about virtual machines already, so they are everywhere. And that's mostly the most popular thing in hosting which now exists is virtual machines. So everything is running in virtual machines everywhere, but there are some things like containers, which is still becomes more and more popular every day. And we have two types of containers, basically. We have system container and we have application container. Containers itself are more lightweight than virtual machines because they don't have to make their hardware virtual. So there are no requirement to make the virtual hardware for every container. So as a result, we have more lightweight environment to run application in. And let's dive deeper to see what exactly it means. So application container, you heard about Docker. So Docker is everywhere now. And that's the most lightweight type of container that allows to run a single application. Of course, that can be multi-threaded and multi-processed, but by design, it has to run single application. System containers like Virtuoso, LXC, or you might heard about FreeBSD jails or Solaris zones. So the idea is that the virtualization from inside the containers of the system is where it look like virtual machine, except some of directories are not writable. So they are like virtual and transferred from the host node. It works for 99% or even more requirements and applications, but still there are some cases on the market that requires virtual machines. So we do not dismiss virtual machines at all. So they have still their use case, but the good thing is to use system containers at least for most of applications, and why we will talk today later. So
just to add here, Igor, so yeah, basically Docker containers, they spread the word about containers in general. That was like somewhere in 2015, if I'm not mistaken. And they had a good marketing for containers. And one of the reasons is that Docker made containers convenient for developers. Before, containers were mainly for admin guys, for them to manage them and to run. Docker made it possible for developers to work with containers themselves. So that was one of the reasons why it became so popular. But again, for example, system containers like Virtuoso, they existed already over 20 years right now, and they are production ready, but they solve a bit different different directions. Like, and here you can see the difference, like between application containers like Docker and system containers.
Yeah, the big difference between system container and application container. So application container is good when you just run a single process. This process is isolated, so it has own namespaces that can has own network, own users, own file system. But the idea is to run a single application inside of it. System container is perfect when you migrate your application from your legacy VM to system container, and you still to container itself, but you're still required to have cron tabs. You have to be able to log into SSH, to do some system daemons and things that are usually not running inside application containers. So system container is, let's say, a kind of virtual machine, but much more flexible, elastic, with a list of features and benefits. And the step number one, if you want to make your application efficient, at least to migrate it to system container. And as phase two, if you want to be true, real cloud optimized, you need to migrate to application container. But it's all like evolutional process. And the migration from VM to system container is simple. So it does not require super extra knowledge of containers at all. The migration to application container requires, but again, it all depends on needs. So as a first step, the migration to system container is mandatory for those who want to be cool, and we will talk about that why. Certified managed containers that we have on our system. So system containers, basically, as we said, it's kind of VM, but in case if that is certified, it has brain inside, and this type of container is managed. So that's the easiest way to start from system containers, to use managed container which is certified, because it has predefined configuration which is managed via UI or API with buttons, or also it can self-configure itself. For example, if the configuration was wrong, or for example, if you don't have experience how to tune these some certain application stacks for your system resources, or if you don't have expertise how to create a cluster, for example, of MariaDB or something more complex. So that's the case for smart containers. Certified containers, yeah.
Yeah, just to clarify here, because we have a question from Elias, system containers can execute multiple services or so, and application containers just only one. So basically, yes. So the ideal option is that in the system container, you can run, like, for example, one main service and some extra services like daemon, SSH daemon, or whatsoever next to it. That's why it's easier to migrate from virtual machine to system container, because they are very similar in the way they are working. So the only, not the only, but some difference is the lightweightness of system containers. But in general, based on some security set and based on services that it's running inside, it's very close to virtual machine itself. And application container presupposes that you run one service inside one container. And so in case with certified managed containers that are available within Jelastic, these are container images that are built by Jelastic team, and they are verified by Jelastic team, and they have inside some tools for like scaling. For also, we are updating the versions of these stacks and of these containers, like stacks inside. So this is an easy way to get started, because you don't need to have like expertise in running containers and building containers from scratch. You can just go to the topology, click the buttons, and get up and running the container with the required stack inside already.
Yeah, so the use case is pretty simple. If you don't need to decompose your legacy big application, and you don't have like many years of expertise how to manage this stack, it's better to use certified template, because the team is cared about that. So we can patch them, we can do the updates, we can do different tweaks and vulnerability fixes, other things. So there is a dedicated team who is cared about, and that's just simple, the easiest way to go. Elastic VPS. So if you need a classical VM, a kind of VM, but again, it's container that allow you to do whatever you want without the smart logic, without intervention of third-party tools. There are VPSs, we call it Elastic VPS, where you can install it on your own. So you can install with Yum, with apt, you can run Debian, CentOS, other systems. So that's just for those cases when you know exactly what you're doing, but you want to benefit from container technology without intervention of any third-party things. Custom Docker containers, and another cool feature, allows to create system container, but from Docker image. So on a Docker Hub, there are really hundreds, thousands of images already created by someone that are designed for specific needs. And if you want to spin up system container just based on that file system, the easiest way to go is to use custom Docker containers. So you can create a system container from file system of Docker. It's really cool because, for example, if you need to do a specific stack which is already packed, you don't have to do the installation on your own. And it really works quite well for many, many cases. Embedded containers, another cool thing. So application containers are able to run inside system containers. Many providers in the world do the same, but they run VMs for that. And VM is not the best thing to run embedded containers because that's a VM. It's huge, monolithic, and it's not so scalable as system container. So in fact, you have like two layers of scalability. One layer is on a level of system container, another level on application container. And the most efficient way to run applications nowadays is to run embedded containers. So that's the case when your application is already decomposed to microservices. It can be deployed to application containers, but as a whole, as more higher level isolational part for your application container is system container. So that's a case number one. And that's the case which is used by Docker CE, by Kubernetes. So the same thing. So embedded containers, by the way, no one on the market provides such a capability to have like two different layers of scalability. When you can on fly without any restarts, any stops, you can just upgrade the instance on fly and do another scaling on the level of application containers. VMs and system containers. So the thing is, when you work with VM, you always pre-allocate resources. So when you create a VM, it's always like 16 gigs, 8 gigs, 12 gigs, and amount of CPUs, but you never be able to scale them normally without intervention. So at least you have to stop the VM, to do the right sizing, to start VM, or if you want to migrate it from place to place, you need to do a stop. The thing is, the thing number one, the containers are scalable on fly without any restarts. The thing number two, they consume much less resources than VMs. As far as memory is not pre-allocated as on VM, because containers that is more about limits, but not about pre-allocation. The amount of containers you can place on a node is much more higher than VMs that will run the same workloads. Kubernetes on system containers, as I said, that that's a kind of top thing what was invented nowadays. So I don't know any other hosting technology which is more advanced when it's Kubernetes for running microservices, and if this Kubernetes is running inside containers. So that is the most efficient case, which is really possible nowadays. There are no other which is much more advanced than that.
Yeah, here to add just to the previous slide. So you can even see if you can go back to the slide. So you can see that first of all, overhead is much lower, and secondly, you see the difference that there are some light green, there is some dark green, and also like white parts. So basically, dark green, this is really consumed resources, and we placed here the same amount in each, and you can see how much of that place within the VM and within the container it takes. Then like light green, this is reserved by virtual machines. And in this case, every virtual machine has its own limit, and all the resources, even if you don't consume all resources inside, all of them are going to be reserved, and you cannot reuse them for other services to run, and you are going to pay for them. And in case with containers, this white part, it can be shareable with other your applications. You can reuse. You will still have these resources in case the load goes up, but this amount will be reusable for other services and applications you have and you run. Yeah, on the second slide.
Sorry, to be totally fair, so there is a technology on a market of VMs that allows to share RAM between VMs called ballooning, but in fact, this technology still doesn't work fine for still today. So technology is really old. They always trying to improve it, but in fact, people still face issues nowadays with that technology. So we do not use ballooning at all because the technology showed that it's not stable.
Yeah, but ballooning is really not useful in practice for most people and scenarios. Honestly, it's yeah.
Yeah, and we have a question in the chat, like the colors are CPU and RAM or both things. So basically inside Jelastic platform, so this scheme is around RAM and CPU, yes, but if we are talking specifically about Jelastic platform, we have a specific resource unit, cloudlet it is called, and it's combination of RAM and CPU. It's like small chunks of resources of CPU and RAM. Like 128 megabytes of RAM and 400 CPU megahertz. So this is like one cloudlet. And thanks to these small chunks, we can grow with a very small scaling step. And that's why these containers are so elastic in our case. You can go to the next slide,
yeah. Kubernetes on VM and system containers. So the difference is if you run Kubernetes on AWS or on Google, on Azure, they are all operating with VMs. And the problem they have always the right sizing. We will also talk about this problem a bit later because there are some important things why it is so important. Usually people don't know about what size of VM to choose. So you need to host your application on Kubernetes. Then you need to think about, you need 16 gigs VMs nodes, or you can go with 8 gigs, or you need 4 CPUs, 5. Sometimes, not sometimes, but usually, when you start to deploy your application, you don't really know yet what resource to scale because there are no obvious answers. So you always will have spare resources. So if your application consumes 8 gigs, you probably will use 16 gigs instances. You can't even create 12 gigs. So there are always bunches when you need to choose and to overcommit your resources. I mean,
yeah, I think that we can move to the slides that are going later, because there is an image that shows this difference, so it will be easier for guys to perceive the information this way. Yeah. Yeah. One small sexy thing just to mention about containers: containers can live migrate, so there is a possibility to snapshot a process and to restore this process on another node. And that allows to avoid downtimes of critical applications if it is required to do hardware maintenance. One of cases also, you can see here at Minecraft game, when the game is migrated from one data center to another data center, and then there are no downtime. So people still remain playing, and the process, once it's freed there, it's resurrected there, the technology works fine. Yeah, and reserved and wasted. So the difference, when you operate with limits, it's easy because your system resources can be used on other stuff. And when you operate with preallocation, it's always a problem of correct sizing. So the thing is that containers are always about limits, not about preallocation. That's a good thing to understand. Horizontal scaling. So containers are really lightweight. As a result, they can scale very quickly. So it's easier, much more easier and faster to scale a container than scale a VM. Scaling of VMs can take 10 minutes, 20 minutes, and hours, depends on the size of VM. Containers are scaled in seconds, especially application containers. So the most lightweight application containers are scaling very fast. Two directions of scaling. So you can scale amount of containers, you can scale amount of resources inside a single container. And these things can happen on fly. So you don't have to restart a VM, a container. So you have to restart a VM once you apply your changes, but you don't have to restart anything inside a container. It also deals with hard disk. So you can increase hard disk just on fly, memory, CPU, network speed, IOPS, other things. So all the things can be managed on fly. This is exactly the slide that are talking about this right sizing problem that Igor mentioned before. So because when you're running like VMs within other cloud vendors, and you need to scale, and usually you need to go and take twice bigger machine and migrate to that machine. So this will require extra work. This will require some kind of downtime during migration. And of course, this can be automated, but again, you need to work on that automation. And also, there will be this over allocation of resources, because even if you need just like a bit of megabytes more than you have right now, you will need to scale and to buy like twice bigger machine, and you are going to pay for all this machine, not like that extra resource chunk that you need. And in case with containers, as you can see here, the container itself can grow or shrink based on the load, like automatically, and provide the required resources. And you're not going to pay for all the resources like within the limits. You're going to pay only for what you're really using. So yeah, and go ahead. Yeah, and another thing, if you even redeploy your application to another node, which is bigger, you still need to do this redeployment and switch the traffic. Why, if you can just rise it with the button? So there is a slider. So these resources are scalable as easy as just as the person just shift the slider. And there is another button, I will show it on a demo, which is responsible for this size. But anyway, so you just need to move the slider, and that's it. And you have a bigger node. And if you have a bigger node, it doesn't mean that you need to pay more for that, because it's just all about limits. And limits are free, resources are paid. But that's another good thing about the system which we use on this paying model. I will show details later. Yeah, reserved. There was and
you can squeeze as much resources as possible just for free, and then your application will be able to scale if you have this configured inside. So all the thing why this slider exists is that just if you need to manage your budget and you don't want to your application to be as hungry just to overlap that budget, but that's it. If you scale just to maximum, it doesn't mean that you have to pay for that. Stateful and stateless. System containers in this case can be also stateful. And for example, if you scale your node, the approach how it works, it takes the first node from the cluster, which is marked as virtual master node, and makes exact copy and join it to a cluster. So your cluster is created from exact copies with same file system, same configuration, same stuff inside that are joined to a cluster. Stateless mode is a bit different. So in stateless mode, you have to, the system will provision empty container, or but empty, it's based on template already, but then you can tweak a logic. We have a specific method how to tweak a logic to container which was provisioned. And there are cases when stateless works faster because something which need to be installed takes less time than cloning of the whole master node, but that's rare case. So in real world, most containers are stateful because they're easier to manage and they are ready to go from the box. So if you have Tomcat with the application, it's easy just to have 10 clones, then do deployment in everyone sequentially. So the case with stateful is much more frequently used in practice. And automated horizontal scaling, another sexy feature. There is a panel in a system that allows to analyze how your applications behaves. And if the practical case is the following, so people are writing scenarios for loading tests using JMeter or any other tool. They simulate load of by having multiple requests from multiple virtual customers. They check how the system behaves on graph, how it's changed, and they create rules. For example, there are triggers based on CPU, on memory, on network, on disk I/O, IOPS. So you can configure your system to scale another node, to create another node in case, for example, if your RAM is up to 80% used, or for example, if your CPU is utilized on that percent. And you can create a rule how many nodes need to be added at once, until which amount of nodes, and how they will be reduced in case if your load will go down. And this really cool instrument because, for example, if you take a look on the configuration which is provided by competitors, the thing is that you have to do all that stuff manually. So they do not provide that to people who are not like used to work on that full-time job, because the proper configuration is a full-time job actually. And many companies who are always developing their applications and they have continuous pipeline, they have to do this stuff all the time. And the instrument which is here allows to do that easily, to have like more quick ability to do that configuration.
Yeah, basically you're not going to waste time on some routine tasks and doing and configuring something that can be automated out of box. So yeah, let's go ahead.
And load alerts in case there are embedded triggers that allows to get alerts in case if you went out of some resources, so you will be able to, you will be notified. And that's also good for scaling, for debugging this scaling feature, and to make the configuration properly adapted for horizontal scaling. Anti-affinity rules. So in 2021, it's really not a good practice to have single point of failure. So the system, when you provision a cluster from same nodes, for example, 10 Tomcat nodes or even 2, the system cares that these nodes will be placed to different hardware, just in case if you lose you lose a node just for any of reasons, network issue, power failures, other things, the system can remain alive, just if that is properly configured and had a proper amount of instances.
Igor, just to say that we have a question here, if we can horizontally scale Kubernetes nodes, worker nodes, and if the scaling is system container scaling is, if so, the process is slow or fast. So that's why I offer right now for you to go to the demo part, and considering the pricing part, we will keep it for the last node, I would say. And because I think that right now you can already show how it works in process, and as well show how horizontal scaling for Kubernetes works.
Yeah, so that's a panel. We have Kubernetes cluster here, which consists of worker nodes, 2 worker nodes, 3 master nodes. They are working in high availability mode. We have storage cluster, which is responsible for volumes provided to Kubernetes. And we have API load balancer. So the case you just asked about is related to worker nodes. So we need to go to configuration, find auto horizontal scaling, add a trigger, find the worker node, and configure. So if the memory consumption on worker nodes will be higher than that, add nodes, and the configuration option. So how many nodes, what is maximum amount of nodes to be scaled, and how they need to be added by 1, by 2, by 3. It all depends on load. So this trigger can be also configured for Kubernetes. And if you have automatic horizontal pod autoscaler enabled inside Kubernetes, so the system, you will get like a flexible cluster. So you may know, so it will not be a requirement to know what the resource consumption will be. If you just set proper limits, the system will live on its own. So you can put workloads, the system will grow application containers, the Jelastic will grow worker nodes. In that case, we will get like infinite scalability up till until the limits of hardware, but that's we never reach them actually.
And also here you can enable notifications, so you can open maybe full screen, this screen with scaling, here. So you can enable in-mail notifications, so in case any nodes are added or deleted, you will be notified about that. So, but again, you have no need to go inside the system, do anything. This will be done automatically by the platform itself. And even if you go inside the dashboard of Kubernetes, you will see like new nodes added or deleted, or any activities that are going on with Kubernetes as well. And to start with, maybe you can show where Kubernetes cluster is laying within because just for you guys to understand that this kind of topology that Igor is showing, this is not something that you need to build from scratch. It's available from marketplace. Yeah, you can go just to the marketplace, or you can go to the
two places where it can be found. If we talk about embedded containers at all, so there are places on the main wizard, Docker tab, and you can find Kubernetes cluster directly right there. Another way is to get it, you can get it in marketplace.
Yeah, there it is in the middle, in the clusters.
Just a second, there was a pen. So you will have such kind of wizard that will pre-configure your cluster due to your needs. You can find a version, you can find what kind of topology that's gonna be. That's a primary topology. So if we talk about development, that should be a single master node and worker nodes. Production will provision API load balancer cluster as a separate tool, which is based on HA proxy that will connect 3 master nodes to a cluster to avoid single point of failure. And and that's it. And the storage will be also clustered based on clusterfs, so you will be able to use volumes also from cluster storage. You can choose the version of the dashboard and ingress controller which is required by your design. So Nginx is by default because it today is the most advanced ingress controller. There are tools for debugging, for monitoring. Remote API can be enabled if you want to manage the cluster, not via the browser, but if you need to connect it to your command line interface. For example, if you are a tech guy, you are living inside console, inside terminal, that's just a proper option to go.
Yeah, and also, for example, you can start with a clean cluster, and then deploy anything there, or you can also go, for example, with pre-configured cluster, and you can, if you have already the project that you want to start the cluster with, you can at once add this project there. And by default, we have OpenLiberty. So if you go to the custom option, yeah, you see here, you will see that we have OpenLiberty inside. So you can at once install it together with Kubernetes.
Yeah, there are multiple ways how to install the application. So you can use Helm, you can use just kubectl. By the way, inside control panel, which is Masternode, there is a web SSH, so you can use normal kubectl tool and other tools which are embedded to manage your cluster with kubectl just directly from a browser. So if you need just to tweak something very quickly and you don't want to connect the external API connection, so if we just run, for example, get nodes, we will see our cluster which is automatically configured. Yeah, let's go to pricing models.
Yeah, maybe before we go again, I think that we can show it with the dashboard. So, for example, if we go to the statistics of the worker nodes, I see that it's already open. In your case, can you open the tab? Yeah. So in the statistics, you can see, for example, RAM, there is a green line of the real usage of the RAM within this Kubernetes worker. And you see that 8 gigabytes, this is like the maximum limit at the moment that is set up for this node. So the system can scale the resources up to 8 gigabytes at the moment. And if, for example, the load goes up, it will give more resources. If go down, it get less resources. You can change this limit here, like for the workers here, you just like drag and you have like more resources. Can you please apply also, like maybe have some other amount and apply? So this will take just a moment or something, and then you will see that this scaling limit, it will be changed at once. But this doesn't change your your payments, because you're going to pay for the same amount of resources that you consume. So you're still going to pay for these 2 gigabytes that are green ones. And yeah, it's better to refresh, like to open from scratch. So yeah, you're still going to pay for these 2 gigabytes, but you see that you have like 24 gigabytes already as a scaling limit, not those previous 8, but you're not paying for these 24. Right now, the system can scale up to 24, but you're still paying for 2. And if you're going to run that, for example, with other cloud vendors with virtual machines, and you decide that, okay, sometimes I have a huge load and I need to have 24 gigabytes or like 8 gigabytes or 16 gigabytes virtual machine, you need to buy it full and you need to pay for all this machine. And just for some spikes that are possible on your platform or on your application. In our case, you're going to pay only for the real consumption, not for these 24 gigabytes, but based on the load that you're going to have. And yeah, now
circuit breaker. So if, for example, you have a marketing activity which is planned just for today, you can move this circuit breaker just to an upper limit, then you can shift it down just to make yourself safe for cases it will not consume more money than you expected. So that's really a matter of seconds. So you don't have to redeploy all this stuff from the very beginning, because it's really a frequent problem that people have to waste time on redeployment. With containers, we don't have to. And yeah, So can we jump
Yeah,
to?
yeah, I think that we can jump to the pricing, and then maybe we will come back for some other stuff to show. So yeah, talking about the pricing, we already started to show that on the statistics that you have this maximum limit, and on this page you can see this difference, like as I've mentioned before, that with other cloud vendors, like VM-based cloud vendors, you are going to pay for the limits. You're going to pay for the full virtual machine. In case with Jelastic containers, you're going to pay for the actual consumption. And if we see, let's go on, if we see with different systems, you can notice that, like, for example, in Linux, there are resources like total resources for macOS or Windows, and there are also notion of used resources, not only like resources in general. Same for cloud computing. It's important to have the same approach here, because there is some kind of limit, total limit, and there is used resources available. So because of that, there is a kind of speculation on this pay-per-use model, because many vendors, they are talking about, okay, you are paying only for what you're using. But then you can figure out that this is more paying for the limits. Okay, you are paying for as you go, because you can grow from smaller to bigger, but still this is not based on the consumption itself. Because if you go to the next slide, there is a sample how it is in AWS. So they are saying that you pay for what you use, but then you go and you buy a full virtual machine with CPU allocated or with RAM allocated, and this is some precise number of resources, and you're going to pay for all these resources. For example, if you choose 16 gigabytes, you're going to pay for 16 gigabytes. Same for other cloud vendors like Google on the next slide. Yeah, so the same idea. And if we go to the next slide, there is some statistics, real statistics. This is gathered from all Jelastic platforms,
connection problem. So yeah, our research showed that real usage. Can you see me?
You hear me, or
there were some connection issues temporary. I think that's fine. So yeah, our researchers showed. So we just grabbed the statistics from more than 100 data centers across the globe, and what we found that people have under allocation of their real resource usage, because everyone wants to be stable. No one wants to have outage because they went out of resources. So that's why people are always trying to get more resources in spare, to keep them spare, just to avoid any possible spikes. So that result, the red line you see, that shows what is the limit. So what people state as a maximum they want to give to their application. And green line shows what is actually used. So you can see people are trying to become safe and trying to allocate more than used in fact. But with containers, it's all about limits. So limit is not the same as consumption. So the thing is that you can pay only for consumption, for real consumption, for just exact number of megabytes you used, exact CPU usage, not about the thing which is like a circuit breaker was just configured just in case, just to keep the environment stable.
Okay, thank you, Igor, for adding that. Yeah, and if we're going to move on with Kubernetes hosting, for example, maybe we can also go to the dashboard again, and you can show some extra functionality that is available for that, not only like scaling and some stuff, but also some tools for management, some add-ons that are available within control plane. Control plane, and some stuff like for updating the cluster and moving on, like that again will help you to save your time, not to waste it on the routine tasks, or not to invest in digging deep.
Let me explain why we jump to that. So the important is the next slide, just to have better understanding. So Kubernetes is the most advanced technology nowadays for application container. But it requires technical expertise to manage it. So it's not the simple thing just to have your services decomposed and deployed to Kubernetes. And to be able to deliver the most advanced product, which exists nowadays, to people who are not 100% experts in Kubernetes, we have all this automation. So we install cluster with all the specific stuff. You just choose on wizard which things you want to enable, and they are there. Another thing are add-ons. So you can install certificate manager. So the system will automatically configure the Kubernetes for you. You just need to write proper ingress files just to have your certificates automatically issued and deployed. GitLab integration, if you already have GitLab, or if you don't have, you can provision it also from Marketplace. So we have a bunch of tools for continuous integration and delivery here. And you can connect it to your Kubernetes with the integration add-ons. You can do the upgrade. So upgrade procedure is really complicated, and I will show you on slides how complicated it is. So the system automates this routine for those who want to try themselves in Kubernetes, but they don't want to waste time on these small technical details and batch of knowledge which is required to run Kubernetes just directly from scratch if you install it from Google or from there. So that system allows to decrease the entry point for those technicians who don't want to spend their time on learning the full techniques of Kubernetes. And yeah, that's the point. As I said, yeah, the installation, default installation looks like that. Just a second. The slide is missing.
Maybe you can show without this preview. No, it's visible there.
A list of things which are already pre-installed. So the system installs automatically ingress controller, enables overlay network based on Viv, has installed core DNS service, metrics server for gathering different kind of metrics. If you need to do proper configuration of your horizontal pod autoscaler, it has embedded dashboard, which is also can be chosen help package manager if you want to use repository of already prepacked software, which can be installed really easy. So you can see the manager. If we just jump to our control plane, the place where we were before, so the helm should be there. So you can manage the installation just directly from there. And yeah, from vanilla Kubernetes, you have to install it from scratch, all these small details, all that stuff, all that configuration. So that's really save time. And yeah, vertical scaling, so per use pricing is available for Kubernetes as well. So it works exactly the same way it works for everything else, because we use system containers for nodes. We can horizontally scale system containers, so why can't we scale Kubernetes horizontally? So the problem is solved automatically.
And vertically.
And vertically. So that's exactly what we're showing on demo. So resources are changed on fly. Yeah, every node is accessible via SSH. So not only Masternode, but also worker nodes, as well as any other system container which is there in the dashboard. So everything can be accessed via web SSH or via classical SSH. It is also possible to upload your own key here and use your classical normal SSH to access the containers. Easy. Upgrade procedure, as I told, that's already a matter of pressing a button, but in fact it looks like that. So there is a flow. Usually what people do, they have a manual, so you have to do this, deploy that, upgrade this node, uncordon it from your cluster, then just upgrade, connect it to cluster again. all the thing is automated, so there are no reason just to go through all the huge manual step by step and do that manually, so the system can do that itself. Addons, as we said, yeah. Embedded cluster monitoring. So we have Grafana and Prometheus, which are available also. If you install the Kubernetes, there is a button to enable monitoring tools. It's not mandatory, but it's optionally. But anyway, if it's production, that's have to be there. So you just say yes, and that's it. And you have, when the system is installed, you will get credentials about all that stuff. And you will be able, what resources are consumed by your application containers, because the system right here shows the resources consumed by system container. So you can see more global picture, what resources are, which resources are consumed and how. But if you want to look inside, you can use Grafana and Prometheus to get more detailed things, which pod from all the others consuming more, which actions are happening there, so you can have more detail.
We have a question. The add-ons are installed by default?
No, so add-ons are not installed by default. You can install them just if you go to your cluster, find out the control plane, that's Masternode, so everything had to be installed from there. And then you just click Install Certificate Manager. You specify the domain, which that should be pre-configured to, and that's it. I don't have domain.
Basically, they are not installed. They are not pre-installed, because it's up to you to decide whether you want to have this add-on or not. Because for sure, some services, they consume extra resources, so most likely you don't need all of them. But here the process is fully automated, so this is a matter of clicking the button. So you just go in the add-ons tab and you click the button install. Maybe sometimes you need to specify some information, for example, like certificate or domain or something like that. But in general, for example, even for cluster upgrades, this is just like click and confirm that you want to upgrade, and it will automatically upgrade to the next level, or that it will automatically install specific service within the Kubernetes. And some monitoring tools that Igor was mentioning, they can be installed together with the cluster, like by default, if you tick it while installation. Again, this is not something that you need to configure. You just tick the button, like tick the point, and you will get it pre-installed inside together with Kubernetes. Okay, so we are already over like timing, so let's move on maybe to the conclusions and because we covered more or less all this information. So yeah, some conclusions, and let's talk about the next steps you can have. So yeah, this is a good opportunity for you to try out this solution together with Beebyte, because guys are providing 30 days fully free for you to check out how the system works, what you can do there, what will be the price for you if you have specific load or whatsoever. You can check it within the dashboard. The dashboards will look the same as Igor was showing demo today. And you can register at the landing page of Beebyte. The data centers, as you might already know, are located in Sweden. So this is going to be local hosting of the Jelastic platform. So you get advanced technology, advanced cloud platform in your country, so close to you, and you can run your projects. You can make those projects accessible for your customers, close to them, and secure within the local data center. And again, 30 days for free, so you can play around. You can get in touch with Beebyte team in order to get some maybe assistance in terms of migration, in terms of assistance with the questions that you can have. And I'm pretty sure that guys are going to be open to discuss everything. Okay, so we have questions. Can you shortly describe the difference of orchestration network between Jelastic and Kubernetes? Igor?
Yeah, so the nodes are living inside private network, which is isolated per customer. So every customer has dedicated isolated space for his system containers. And you can also create isolated group inside your tenant. So if you have multiple projects, you can have isolated networks between the projects. But if you install Kubernetes, that creates extra overlay network on top of your network. So this overlay network is provided by Viv, and it has own IP space, IP subnet, which is not conflicting with your services. So there were multiple ways how to access the service inside Kubernetes from we have, by the way, we have articles about that. There were multiple ways. You can expose a port. You can have ingress rule. If that is HTTP request, you can have ingress rule. If that is a TCP port, you can expose it to all your working nodes. So in that case, all your working nodes will have a port which will be listening this node port. So that way, any other service which is provisioned within this panel can also access a certain service inside Kubernetes. There is a port forward option as well, and there is ability to install MetaLLB in case if you want to have external integration. There is also an option to, I think that's it, yeah. So there are multiple options how to connect. There is also VPNs and other things, but by default you can expose a port on worker node from any service which is running inside and connect to it either from public network from the internet or just directly from that services. And inside Kubernetes there is also a namespace. So there is a default naming for interconnection of your microservices inside Kubernetes. So there is a default namespace. You can just place the name of your service, and then your pods inside Kubernetes will be able to communicate each other within this overlay network. And exposing is only used when you need to connect to outside service or ingress. Ingress is really frequently used just for HTTP kind of requests.
And we have one more question. Is there any handling of secrets in Jelastic similar to Kubernetes and Docker?
These systems use default airbag models, so the secrets on Jelastic is not connected to secrets inside Kubernetes. So you have default scheme, so your secrets are living there as usual. Just a second. So you have all the secrets there, but they are not connected to the system, so they are isolated. Whatever many clusters you provisioned, every cluster will have its dedicated airbag system, which is fully embedded, and it's living on ATCD, so it's not connected to Jelastic out system at all.
Okay, great, thank you. So there is also a question about the session, if it's recorded. Yes, it's recorded, and Beebyte team is going to make a nice cutout of this session, and we'll share the video recording, and also we'll share the presentation that we are showing today. So you have a choice to check the video again or to check the slides. And again, if you're going to have any other questions, you can drop a message to me, to Igor, to Beebyte team, Simon, or in general to the support. Okay, any other questions? That's great that we had so many questions during the presentation. So it shows that you're interested in the products and you're interested in the platform. So again, you can try out that by yourself, and while trying, maybe you're going to have some extra questions, so you can get in touch with us. And it seems to me today we more or less covered the main points. Simon, do you have anything to add here?
No, I mean, I would just like to thank you, Tatiana and Ihor, for a great presentation. It was a lot of great content, and I really hope that you know, people come out of this a bit wiser in the ways of container hosting. But I thought it was a great presentation, so thank you very much.
Great, thank you. Sure, that's a good point. We really want for people to understand better the technology itself, how to use it, for what use cases it's more appropriate. So surely in future, if you're going to have any questions, guys, feel free to get in touch with us and go ahead and try the product. So we'll be glad to get your feedback and maybe improve some stuff in future. Okay, so one more question, that's perfect, about stateful cloudlets in Jelastic. Do you recommend placing database inside Jelastic cloudlets? So just to say that containers are not called cloudlets. Cloudlets is a small piece chunk of resources inside container, and stateful or stateless, this is about the container itself. So for example, databases, we have a set of certified databases available out of box from the topology. And you can choose whether you want to have them stateful or stateless, but Igor can share ideas what is better in this case.
Yeah, so the system is automated, so we use stateful approach for databases. So it also has scaling, and but the stateful is not in that case means that it just makes a clone. It also does the configuration. So once your node is created, it has logic which is executed every time when the node is attached or detached. And we have this proxy SQL cluster, which allows you to have a single entry point for the clustered solution with no point of failure. If it's Java, you can use JDBC just directly to connect to cluster, because JDBC is kind of smart driver, which allows to have multiple backends and manage the logic of a cluster as well. So different options are possible, and those packages like WordPress, which have out of the box, already have these clusters embedded. So when you provision a cluster of WordPress, just from here, you also get not only a cluster with WordPress, but database as well. So let's full-featured tank with all this stuff. Boom. So yeah.
Okay, great. Hope that answers the question. So any other questions?